In this video, we're going to explain how recursive evaluation of a binary tree works. So when we think of recursion, this is how most trees are going to be evaluated. So at every node, you have, if it's a number, you're just going to return the value, return it. Now, if it's an operator, your code has to recursively evaluate left, recursively evaluate left. Then you have to recursively evaluate right. Then you apply the operator. And then you return your result. The reason why is because a binary expression tree is recursive, and each subtree itself is a complete expression. And we're just combining them. We're linking those nodes. With pointers. Because really, a tree is just pointers and references. So our algorithm is just a math structure like that. So for example, take 9 minus 3 times 2 plus 4 divided by 3. So you have division sign here. That's going to be your parent node. Down here we have 9 and 3. So now for a recursive evaluation of this, what we're going to have is code like this. You have double evaluate. So your base case is going to be your leaf node. So first we have if node.leaf is null. So we check if the first one is null. And if node.right is not equal to null, we first check if the tree is even having values on the left and right, and if this is not a leaf. So return double.parse double node.value. Now we have a recursive call. So double left value is equal to evaluate node.left. Double right value is equal to evaluate node.right. Now we have our apply operator. Switch node.value. Case plus, when we have that case, we're going to return left plus the right value. Case minus is return left value minus right value. Case times is return left value times right value. And case division is return left value divided by right value. So let's walk through some recursive calls. So let's say if we call different things. Let's say we call evaluate root division. So if we call evaluate root division, this is going to call evaluate times and also evaluate 3. So now we are going to evaluate the right side, which is 3. So it's going to be a leaf node. So you're just going to return 3. Now your left side. Structure like this, actually. Left-hand side, you're going to have to evaluate times. So at the node times, this is going to be an operator. So that means you're going to have to call two things. You're going to have to call evaluate minus and also evaluate plus. So for evaluate minus, you're going to have evaluate minus, it's going to call eval 9 and also eval 3. But thank goodness both of these are going to be leaves, so then you can just compute. So that's going to be 9 minus 3 is equal to 6. So then you're going to return 6. Now after this, you have to evaluate the, so that's your left-hand side of that. And then you have your right-hand side of this. So your right-hand side of this is eval plus. For eval plus, I think it's better if we just do this. Like it looks like a tree. Evaluate plus. So this is going to be calling eval 2. And also, actually, I just realized this is actually switched. This is right-hand side and this is your left-hand side. Ignore that for now. So evaluate 2 and then also evaluate 4. So evaluate 2 and 4, these are going to just return 2 and 4. So you're going to compute that. And we have plus 2 plus 4 is equal to 6. Return 6. So now you have to go back up. So now that you have 6 and 6, it's going to be times, right? So because it's times, we have the 6 from that side and we have our 6 from the other side. And then that's going to result in 36. So now we have to go back up to division. So let me take this. So division. On the division side, you have here. And then you have, on the other side, you have this 3. So this is going to result in 36 divided by 3. And it's a different, wait, no, I want that to be the same color. 3 divided by, and then this is equal to 12. So 12 is going to be your answer. That's your final result.